Hello students, welcome to AIMS India online classes. This is a chemistry session. Here we are discussing about periodic classification. In the earlier sessions about this chapter we have seen some concepts that is classification of elements by different scientists, periodic tables and modern periodic table, how the elements are segregated in the modern periodic table and the variation or trending of periodic properties in the modern periodic table we have seen. Now, based upon these all concepts, we are going to see practice sheet on this chapter. So here we are going to see the practice sheet 2, which contains different kinds of questions like multi-correct answer type questions, comprehension paragraph, matrix matching, analytical approach. In this way, different kinds of questions we are going to see in this practice sheet. Let us start that. So first of all, let us see the multi-correct answer type questions from this chapter. So here each question may contain one or more than one correct answers. So choose wisely, read the options carefully. See the first question. Which of the following statements about modern periodic table are incorrect? They're asking to find out the statements which are not correct regarding modern periodic table. So about the arrangement of elements it is given here. We know in the modern periodic table, elements are arranged in the increasing order of their atomic numbers. So we say modern periodic table, periodic law. Modern periodic law we can state as the physical and chemical properties of the elements are periodic functions of their atomic numbers. So elements are arranged in the increasing order of their atomic numbers in the modern periodic table. So except the remaining will be incorrect. See first one, elements are arranged on the basis of their decreasing atomic numbers. So it is incorrect. What about the next statement? The elements are arranged on the basis of their increasing atomic masses. No, it is also not correct. Because atomic mass is not the basis, they have taken atomic number as a basis for classification in the modern periodic table. Third one, isotopes are placed in adjoining groups in the periodic table. Actually, there is no question of isotopes in the modern periodic table because this is based upon the atomic numbers of the elements. So even though there are different number of isotopes, all will be having the same atomic number. So all the isotopes are given the same place, no adjacent places. Only we given one place for all the isotopes because they contain same atomic number. So this is also an incorrect statement regarding modern periodic table. See the last one. The elements are arranged on the basis of their increasing atomic number. Yes, this is the only correct statement about modern periodic table. Now what will be correct answer now? First three, because there's three are incorrect statements, isn't it? Next question. The elements that have a single electron their valence shell or outermost shell. So which elements will be having single electron in their outermost shell? The elements of first group. Alkali metals they have single electron in their valence shell. Say the first group elements among these, those will be correct answers. We know hydrogen, lithium, sodium, potassium, rubidium, cesium. These are first A group elements, isn't it? These all elements will be having one electron in their outermost shell. So those will be the correct answer here. Hydrogen, lithium and sodium. These three are having single electron in their outermost shell. Whereas aluminium, it belongs to third group and it has three valence electrons. Three electrons in its outermost shell. Okay, except that remaining three are having one electron. Right, next one. Helium is an unreactive gas and neon is a gas of extremely low reactivity. What, if anything, do their atoms have in common? Are they having any common property? Because helium and neon both are least reactive, actually, you say. Helium unreactive, and even neon also almost completely unreactive, very low reactivity. So to be these less reactive, what property is being in common with those? See the first one, both have completely filled outermost shell. Is it correct? Yes, because if you see helium, atomic number is 2. If you write con 1 as 2 or 2 is its configuration, means first shell is completely filled for it. It is last shell for that, so it is completely filled. Whereas if you see neon, its atomic number is 10. If you write configuration for this, 2 comma 8. So second shell is completely filled with 8 electrons. Both are having completely filled outermost shells, hence they are least reactive. This is correct relation between them. Second statement, both have stable electronic configuration. This is also correct because helium has duplet configuration whereas neon is having octet configuration. So both are correct. Next, both have 8 electrons in their outermost shell. Is it true? See neon, it is having 8 electrons in its outermost shell, second shell. But helium, it has only 2 electrons in its first shell. So this is incorrect. Fourth statement, both belong to same group in the modern periodic table. Yes, this is also true because these two elements belong to same group, that is zero group, which we also call as 8th A group, that contains elements like helium, neon, argon, krypton, xenon, radon. So these two are in the same group. So these are the properties being in common to these two elements by which they are becoming least reactive. Okay, these three are correct. Next one, which among the following elements have sudden increase between second and third IP values? We have to understand one thing here. To be sudden increase between the second and third IP values, the element should have two electrons in its valence shell. Then what happens? After the loss of these two electrons from its outermost shell, it attains nearest noble gas configuration. By that, the removal of third electron requires greater energy. What they asked, well, let us see once again. Which of the which among the following elements have sudden increase between the second and third? Yes, that's the same. So to be the third IP value much greater than the second, the element should have two electrons in its outermost shell. By that, if it is lost two electrons, it will be attaining nearest noble gas configuration for its M plus 2 ion. So the removal of third electron requires a large amount of energy when compared to second and first. Okay. Now see here, the elements which are having only 2 electrons in the valence shell, those will be having this difference, right? See magnesium, atomic number of magnesium is 12. Its configuration 2, 8, 2 means it has 2 electrons in its outermost shell. So when these 2 electrons are removed, the removal of third electron requires large amount of energy. In that way, there will be sudden increase between second and third IP values. So this will be correct. We see aluminium, it has 3 electrons in its valence shell. So it won't have any much gradation. Sudden increase won't be there. There will be gradual increase only. Whereas sodium, it has only 1 electron's valence shell. After the loss of 1 electron, there will be sudden increase between the first and second IP values for this, but not between second and third. Okay. Next, if we see calcium, calcium also having 2 electrons in its valence shell. By the loss of these 2 electrons, there will be sudden increase, high increase between the second and third IP values. So now I can say second group elements will be having sudden increase between the second and third IP values because they have 2 electrons in their outermost shell. After the loss of these 2 electrons, they attain stable noble gas configuration. For the removal of third electron, they require large amount of energy. Okay, now we can say these two elements, magnesium and calcium. Okay, next one. IP2 value is more than IP1 Because for any element, IP2 value will be always greater than that of IP1 value. This is because due to the increase in effective nuclear charge, that's correct. Due to decrease in size, this is also correct because as number of electrons are being lost by the element, its size gradually decreases as nuclear force increasing on outer electrons. So due to less number of electrons, this is also correct. As number of electrons is being decreased, then nuclear force of attraction on the remaining electrons will be much greater. So because of these three factors, IP2 will be always greater than that of IP1 for any element. Next one, the correct order of electron affinity. What is electron affinity? The amount of energy released by an atom while gaining an electron in its neutral isolated state. Now, in a group from top to bottom, electron affinity decreases because size increases gradually. So if you observe the options given, there will be certain relation between the two elements given in option. If you observe sulfur and oxygen, what relation do they have? Both they belong to same group. We know in a group from top to bottom size increases, hence electron affinity decreases. So in fact actually should be having sulfur should have lower electron affinity than oxygen, but because of a smaller size of oxygen, sulfur is having greater electron affinity than that of oxygen. This is correct. But in case of sodium and potassium, if you see from top to bottom, electron affinity decreases here. So the topper element, sodium should have greater electron affinity. But they mentioned here, potassium is having greater electron affinity. It is wrong. And the next, chlorine and fluorine both belong to same group. Top to bottom electron affinity decreases. But here, in the case of these sixth period and sixth group and seventh group elements, the second element in that group is having the greater electron affinity because of the very small size of first element. Whatever your explanation we told here, the same we can say here also. So actually fluorine should have the greater electron affinity, but it has lower electron affinity than that of chlorine because of very smaller size of fluorine, right? So chlorine is having greater electron affinity than fluorine. What about iodine and bromine? It decreases from bromine to iodine because iodine is having greater size than bromine. So they mentioned in the incorrect way. Now what will be the correct answer? A and C. Okay. Next one. Which of the following is correct regarding atomic size? So let us say in common. What happens to the atomic radius or atomic size in the groups and periods? We know in a period from left to right, some atomic size gradually decreases. And in case of group, from top to bottom, atomic radius or atomic size increases. Now what they have given, let us see here. Decreases gradually from left to right. This is correct. Left to right means in a period. Gradually, it decreases from left to right in a period. Increases gradually from top to bottom. This is also correct. Top to bottom means in a group. In a group, from top to bottom, atomic radius or atomic size increases. This is also correct. Now, if you see third one, iron Fe has less atomic size than Fe3 plus. Fe3 plus is formed by the loss of electrons, isn't it? By the loss of 3 electrons, Fe3 plus is formed. By the losing of electrons, nuclear charge increases because number of electrons will be reduced. So size will be shrinked. Now Fe3 plus will be having smaller size than Fe, neutral atom Fe, but they have given here in the reverse way. So it will be incorrect statement. Next one, F minus has more atomic size than F. Will be true? Of course, yes, because F minus means fluorine gained electron. By gaining of electrons, the size of the atoms increases. Anions are having greater size than neutral atoms because they will be having extra electrons. Between the already existing electrons and this extra electron, some repulsion occurs. To overcome the repulsions, the size of the outermost orbital will be a little bulges. Electrons move a little away from the nucleus to reduce to minimize the repulsions between them, and hence size will be increased. So F minus is having greater size than that of F. So this is also correct statement. Now what will be correct answer now for this question? A, B, D. Right? Next let us see comprehension passage. Read the passage here given. The number of a period in which the given element is present is equal to the valency shell number of that element. Yeah, the number of the maximum shell present in the electronic configuration of element gives its period number. Now let us see questions based on this. See the first question. The number of elements present in third period is. How many elements are there in the third period? We know first period has only two elements, hydrogen and helium. That's why you say very short period or shortest period. Second and third periods are having 8 elements in each. So they are called long periods, or sorry, short periods. Both are having 8 elements in each, so they are called short periods. Next, fourth and fifth periods they are having 18 elements in each, so they are called long periods. Sixth and seventh periods are having 32 elements in each, so they are called longest periods or very long periods. Now they asked here about the third period. It has 8 elements. Okay. Next, the longest period in the periodic table. Which period is longest? Just now we told the periods 6th and 7th are having totally 32 elements in each period. So they are called very long periods or longest periods. Now, out of these two, sixth period is given here. So that will be correct answer. Next, which among the following elements are known as typical elements? We know the sixth period elements are known as typical elements because based upon the properties of these elements, the properties of the remaining elements in that group can be predicted. That is why these elements are said to be typical elements. They are third period elements. Okay. Next, see the passage one more it is given based upon the ionization energies. The second IE are higher than that of first IE. This is mainly due to the fact that after the removal of the first electron, the atom changes into monovalent unipositive ion, and hence IE2 will be greater than that of IE1, isn't it? So based upon this, let us see the questions now. Successive ionization energy of an atom is greater than the previous one. This is because why it is second ionization potential is always greater than IE1, and third IE is always greater than second IP, fourth IP is greater than that of third IP, and so on. Why it is so? Why what is happening? This is because protons by electrons ratio increases. Here in the options if you observe P by E is mentioned. Here P represents number of protons, E is number of electrons. As number of electrons are being released or taken out by from the atom, gradually protons number increases than number of electrons. So P by E value will be increased gradually. That is why IP values will be increasing from first to higher values. Okay. Now here P by E ratio increases. This is the main reason. Right. Next one. Correct order of IP of coinage metals. So what are coinage metals? We know 1B group elements in the periodic table. They are copper, silver and gold. These metals were used for making of these coins. That is why they are called specially coinage metals. So how this ionization potential vary among these coinage metals? What relation between these all coinage metals means they all belong to same group, 1B group. We know in a group from top to bottom atomic size increases as the one shell is being added element to element. So as size increasing, ionization potential decreases. So if you see the elements in the 1B group like this, first copper and then silver and at last gold. So from copper to gold, size increases and IP value decreases. Now which will be having greater among these all? Copper. Next is silver. And at last gold. Where it is given copper, silver, gold. This is correct answer. Okay. Next one. IE1 and IE2 of magnesium metal are 178 and 348 kilocalories per mole respectively. The energy required for the given reaction, that is magnesium gives magnesium plus 2 and 2 electrons. So to become magnesium into magnesium plus 2 ion, 2 electrons should be removed. So for the removal of first electron, the amount of energy required is this much. And next to for the removal of second electron, magnesium requires this much amount of energy. So for the removal of both the electrons from magnesium to convert into Mg plus 2 ion is the sum of these two. How much it is? 526 kilocalories per mole. Where it is? Here. The same quantity shown with the minus symbol one more. Here, negative symbol represents evolution of energy, exothermic process. But here, the removal of electron requires certain amount of energy. So as it is being endothermic process, we represent it with the plus symbol or without writing plus symbol. So that is why second option is correct. Okay. Next, see matrix matching type question. In the column 1 here, they have given a certain group of elements and their special name is given in the column 2. Try to match these two. See first one, alkali metal. So 1A group elements. 1A group elements are commonly called alkali metals, isn't it? Next, second A group elements. Second A group elements are called alkaline earth metals. Why first A group elements are called alkaline metals? Do you know? Yes, we discussed about this. Because first group elements, they form bases which are soluble into water. So the bases which are soluble into water are called alkalis. That is why these first A group elements are called alkali metals. Second A group elements are also forming bases which are soluble into water. And even one more additional property is mostly they are available from the earth crust. So based upon these two properties, second A group elements are called as alkaline earth metals. Next, the seventh A group elements. Seventh A group elements are fluorine, chlorine, bromine, iodine, and oxygen. These elements are called halogens. The meaning of that is salt formers. Okay, seventh A group elements are called halogens. Next, eighth A group elements. They are helium, neon, argon, krypton, xenon, and radon. These are called rare gases and noble gases also. These two are the names of 8th A group elements only. Okay, try to match these now based upon these properties. Check the matching ones. First group alkali metals, second group alkali earth metals, 7th A group halogens, 8th A group rare gases or noble gases. Okay, let us see one more matching. Here they have given certain hints here in the column 1 and the elements names are given in the column 2. Try to match this. What are the units of ionization energy? We know it is an energy, it will be having units kilojoules per mole or kilocalories per mole. Next, highest ionization energy is for which element? The element with the highest ionization energy is smallest sized noble gas, that is helium. Next, highest electronegativity is therefore the element with the highest electronegativity is fluorine. Next, highest electron affinity is for chlorine, isn't it? Now try to match these units of electron affinity. Ionization energy are kilojoules per mole or kilocalories per mole. Highest ionization energy, helium. Highest electronegativity, fluorine. highest electron affinity, chlorine. Okay, this is the correct matching. Next statement type questions. See the first statement given in the question. Atomic radius of an element, atomic radius of the elements increases as we move, one moves down first group of the periodic table. So in a group from top to bottom, atomic radius decreases for the elements. Is it correct? Yes. Atomic radius increases. Yes, it is correct, because from top to bottom, if you see in the first group, from one element to another element, as we move down, a new shell is being added. If we see hydrogen, it has only one shell. Next, lithium, two shells. Sodium, three shells. In this way, top to bottom number of shells for an element increasing. As number of shells increases, obviously size of the atom also increases. So we can say atomic radius of the elements increases as we move from top to bottom of the first group of the periodic table. This is correct. Correct statement. See the second statement. Atomic radius of the elements increases as one moves across from left to right in the second period of the periodic table. So what happens in the second period? Not only in the second period, we can say in generally in a period from left to right. In a period from left to right, atomic size decreases. Even though the atomic number is being increased, nuclear charge increases on the outer electron cloud and hence size decreases. So among second period elements, atomic radius decreases. So this is also correct statement. Now what will be correct answer? As both are correct statements, this will be correct answer. See one more question. The elements in the modern periodic table are arranged on the basis of their decreasing atomic number. Is it correct? No. They are arranged in the increasing order of their atomic number. This is correct. First statement is wrong, second statement is true. Where it is given here. Statement 1 is incorrect and statement 2 is correct. Okay, next one. Analytical approach type questions. See the first one. Which one of the following depict the correct representation of atomic radius of an element or an atom? What is meant by atomic radius first? It can be defined as the distance between the nucleus and outermost orbit of an atom is called atomic radius. So the size of the atoms is compared based upon this atomic radius. This atomic radius is defined as the distance between the nucleus on the outermost orbit of that atom. This is considered as atomic radius. So this will be the correct representation of the atomic radius definition. Whereas if you see for the remaining, the distance is not taken from the nucleus to the outermost orbit. It is taken to middle orbits. That won't be correct definition for atomic radius. Isn't it? Right. This is a correct representation for atomic radius of an atom. Okay. This is about the practice sheet 2 regarding periodic classification chapter. Thank you for watching our video. Please subscribe our YouTube channel Aims Today for latest updates and recorded videos.